Alright, today we're going to be looking at infrared sensors for robotics. This is a proximity sensor. It's one of the basic sensors that you're going to be using in robotics all the time. There's two types. One, IR, which answers the question, is there something in front of me or is there not something in front of me? And then there's sonar, which tells me, well, there's something in front of me and it's 2 inches away. Maybe it's 1 inch away, but it can tell where it's at based upon sonar. Now, infrared is based on light, so light is very quick and light has a good response time. Sonar has to bounce back. It's a little slower, but there's another thing sonar can do. It can detect thinner objects. Okay, so if I took, let's see what I got around me right here. If I took this file and put it in front of the IR sensor, it's not going to detect it until it's like really close, like this. Okay, but if I turn it on its side, it immediately turns on. So that's pretty accurate though. This is a file, and we're talking like that's 1/4 of an inch. And then when it gets to the side, look at I'm pretty far away, and it's still detecting it. That's good. So there's a couple different things you can do as far as purchasing the IR said things. And one, you can go the expensive route. And the expensive route looks like this. So if you go to SparkFun, you can type in IR or infrared, and you can look at these things. Here's an infrared proximity sensor, short range and long range. Long range is always out of stock anyway, so you don't have to worry about buying these anyway. But if you look, they're $14.95, and let's say you have 6 of these on your little robot. That gets pretty freaking expensive. Now, there's nothing that this thing does that 2 other things can't do. So if I wanted to build inexpensive sensors, I could build them for like about $3 each instead of $13.95 or $14.95. What you're going to be needing is a couple parts. One of the parts could be purchased, actually 2 of the parts could be purchased at Radio Shack if you want. This one is an infrared LED. Okay, this is 940 nms, which is how bright and what frequency it's running at. It is 1.2 volts and 100 milliamps. So you'll need a resistor for this, and if you go back to chapter 2, you can calculate that resistor. Ha ha ha. Thought I'd do the math for you, right? But you're going to need a resistor, trust me on this, because this is 5 volts and this is 1.2 volts. Even though the 100 milliamps is in place, it will not last long, and you need it to last long. So what's happening here is, you know, this infrared light is shooting a beam that I can't see, that functions very well in daylight, in the dark, whatever, because it's actually at a higher frequency than normal light. And then this little guy right here is picking up that, being reflected off my hand. So it's like a flashlight that you can't see, and this little guy right here detects that light bouncing off of me. If you use a standard video camera, one of the older models, you can actually see this happen real time. You can also use a cheap cell phone. Don't try it with an iPhone, it doesn't work. So I have to use, you know, usually some really cheap model of, or inexpensive cell phone with a CMOS camera. Now the little guy that picks up the IR, he can be purchased at Radio Shack also. I don't have the package for him, but he's a diode, so infrared receiving diode. And you can also buy him at SparkFun. He is located right here. Now there's different variations of these. So let me kind of show you a data sheet. So this one, and this is how kind of SparkFun works. So you have an object out here in SparkFun land, and sometimes it's labeled, sometimes it's not, for the actual what frequency things run at. So in this case, they hit it in the name, TSOP 38 Hertz. So this is a 38 Hertz IR receiver diode. But if you go into the data sheet, you're going to find out that there's more. There's a 56 kilohertz. Okay, and this represents the speed at which it can return also. So a 56 kilohertz will return light much, or receive light much quicker, and the response time is greater. Now if you have more of these going on, okay, let's say I have 6 of them on a model that needs to be detecting proximity. If you get too many of the 56 kilohertz, you're going to have to look at a different processor other than Uno to run that, and that's the do, or do, but somebody's like, you mispronounced do and you should pronounce it do. If you spell out do online, it's the same do. So I'm going to have to do some research on that on some foreign websites based in Italy to find out the pronunciation of do, because I feel ridiculous saying do every time, especially online. Alright, anyway, so that's what I'm saying. 56 kilohertz, higher processing power is required to power many of these. Okay. Also, you can buy that at Radio Shack. Radio Shack, you can see it here, 38 kilohertz infrared IR receiver module. Cool. And also, you see there is a couple different NM ratios for the light emitting diode for the infrared. So if you look here, I have a 950 NM. The Radio Shack one is 940 NM, and this one is 850 NM. Okay, this is good for other purposes, but not what I'm using for as far as proximity is concerned. You want 940 above. It doesn't matter which one you get, the 940 or the 950, because really you have to pulse this light at 38 kilohertz. And that's why the last lesson was so important about kilohertz and frequencies and everything else, because now you understand, you know, if I'm just blinking a light faster or slower, the actual IR can be picked up. Cool. So now that we know what we're getting, see, this is 95 cents, and this one is $1.95. Or you can get the sweet $14.95 one that does the same thing. Your choice. But once you get your shopping list, come see me in the next video. Enjoy.